Hey everyone, and welcome back to another explainer. Today, we are going to cut right through the hype to look at the mechanical realities and the actual structural layers beneath generative AI. If you've ever found yourself wondering how these tools actually function under the hood, well, you're absolutely in the right place. Let's get into it.
So, Tom Freston once said, innovation is taking two things that exist and putting them together in a new way. For pretty much all of human history, we just assumed this kind of artistic synthesis, writing poems, designing fashion, composing music, was strictly a human trait. But the generative AI revolution completely flips that on its head. It literally takes massive amounts of existing training data and combines it in entirely new ways. And honestly, the results are becoming totally indistinguishable from human craftsmanship. All right, here is our roadmap for today. We're covering 1. The generative AI revolution. 2. The 3 layers of AI. 3. How AI learns. 4. Co-creating with machines. 5. The 4 big limitations. And finally, 6. The future of work. Section 1. The generative AI revolution. Moving from analysis to creation. This shift from analysis to creation, it is a massive paradigm shift. Think of traditional or discriminative AI as a super efficient mail sorter. It basically learns boundaries to separate data into distinct classes, kind of like sorting your emails into spam or not spam. But generative AI, it's more like an artist facing a blank canvas. It infers the underlying probabilities of the data to paint entirely new, synthetic samples based on patterns it's learned. Section 2. The 3 layers of AI. That's model, system, and application. Now, you might be wondering, how does a raw mathematical concept actually become a product you can use on your phone or computer? Well, it happens across 3 distinct layers. First up, you have the raw model layer. Think of this as the underlying brain, so GPT-4 for text or Stable Diffusion for images. But you don't actually use the model directly. It gets embedded into a system level, which gives you an interface, like ChatGPT or Midjourney. And then finally, that system is deployed at the application level to solve a really specific business need, like, say, generating SEO content or automating code synthesis. Section 3. How AI learns. Let's take a peek inside the black box. First up is the transformer architecture. And yes, this is literally the T in GPT. Unlike older neural networks that had to read text sequentially, just word by word, a transformer processes an entire input sequence all at once. It uses this amazing thing called a self-attention mechanism to weigh the importance of different words in context. This is what allows the model to grasp the true semantics and meaning of an entire document simultaneously. It's a real game changer. Then we have GANs, or generative adversarial networks. The best way to think about this is like a super high-stakes game of cat and mouse. You essentially have 2 neural networks fighting in a zero-sum game. The generator network tries to create fake data, while the discriminator network tries to catch the fakes by comparing them against actual training samples. Over time, this adversarial loop forces the AI to create hyper-realistic synthetic data that the discriminator eventually just cannot tell apart from reality. But if we're being honest, the absolute secret sauce that makes systems like ChatGPT feel so incredibly human is RLHF, reinforcement learning from human feedback. Instead of just predicting the next word, it trains a reward model directly from our feedback. Humans rank the quality of different outputs, and the AI optimizes its behavior to align with human preferences. This is exactly how it ensures its answers hit the perfect length, style, and appropriateness. Section 4. Co-creating with machines, a new socio-technical view. Historically, interacting with computers has been entirely about human delegation, right? You assign a specific task to a passive artifact with very strict predefined rules, like punching numbers into a calculator. But today, we are moving straight into co-creation. We're collaborating with agentic AI. You provide a prompt, the AI interprets your intent, and it gives suggestive feedback that actually subconsciously informs your next move. It's a proactive, two-way partnership now. Because of this totally new dynamic, we need what researchers are calling a theory of the artificial mind. I mean, challenge yourself for a second. Think about how quickly you start attributing human-like intent or maybe even emotions to a chatbot when you're interacting with it. We automatically use our human social skills to predict what the AI will do next. So to collaborate effectively going forward, we need a formalized theory to explain how we perceive the rationale of these highly intelligent systems. Section 5. The 4 big limitations. time for a quick reality check. Look, the potential here is massive, for sure, but there are 4 major technical boundaries baked directly into these foundational models. First, incorrect outputs. Second, bias and fairness, because these models can easily amplify human stereotypes found in their training data. Third, copyright violation, since models often produce derivative works without original creator compensation. And finally, environmental concerns. Let's zoom in on 2 of these real quick.
First, those incorrect outputs, which are widely known as hallucinations. You have to remember that these models are fundamentally probabilistic. They just generate the most probable response, not necessarily the correct response. A hallucination happens when the AI confidently spits out text that looks completely plausible and sounds great, but is factually entirely wrong or just complete nonsense. And that makes their outputs incredibly difficult to verify unless you are already an expert in the topic. 552. Let that staggering number sink in for a second. That is the estimated tons of CO2 emissions produced just to train the GPT-3 model alone. That roughly equals the annual carbon footprint of dozens of households. The sheer computational horsepower required to train and run these massive neural networks poses a massive environmental and sustainability challenge for us moving forward. Section 6. The future of work and its implications for businesses. Zooming all the way out to the big picture, the macroeconomic impacts, the numbers are wild. Estimates from Goldman Sachs suggest generative AI could raise global GDP by 7% and potentially replace 300 million knowledge worker jobs. The economic stakes for organizational adoption and digital leadership are incredibly high right now. This isn't just some cool novelty. We are looking at a fundamental restructuring of economic productivity. Businesses are about to completely transform how they manage and share unstructured knowledge. We're already seeing entirely new job profiles emerging, like prompt engineers whose entire core competency is interfacing effectively with these models. Those static, dusty company handbooks, they're going to be replaced by dynamic, intelligent process guidance systems. We're going to see AI-driven enterprise modeling, digital twins of organizational processes, and automated synthesis for everything from software code to your marketing content. So I want to leave you with this final provocative thought. Are you just going to use AI, or are you going to co-create with it? It is really time to stop thinking of generative AI as just another passive tool sitting on your desktop. The future belongs to those who prepare for true human-AI hybrid intelligence. Thank you so much for joining me on this explainer today. I really hope this helps structure your understanding of what's going on under the hood, and I will catch you next time.